Good evening, ladies and gentlemen. We're just about ready to get started. It's a full house, outstanding attendance tonight. Thank you all so much for coming. My name is Stephen Franklin. I am the President and Vice Chancellor of Trent University, and it's my honor to welcome you here this evening to a lecture and a panel discussion entitled, "For the Sake of Our Lakes, Global Change and Its Effects on the Lakes of Ontario." This lecture is a prime example of the strategic priorities currently being considered at Trent. The university is now considering new initiatives, such as a water science degree and a Center of Excellence in Water Quality. Tonight integrates the important philanthropic objectives of the university with its academic expertise. And tonight is a special occasion for Trent University as it celebrates the first endowed professorship at the university. An endowed professorship is a gift from a philanthropist, in this case anonymous, that enables the university to create a prestigious academic position and then recruit and retain the best and brightest scholars and researchers to the position. This professorship position sits in the framework of the Center of Knowledge in the Environment. And this Center of Knowledge is a lens through which Trent is able to showcase its intellectual capital, world-class faculty, and the engine that drives innovation and student success while providing targeted opportunities for philanthropic investment tied directly to Trent's academic and research plans in the field of environmental science. The Center of Knowledge in the Environment was launched in 2009 with a series of events and announcements, including the establishment of this first endowed professorship that was named in honor of Dr. David Schindler. David Schindler began his career as a professor at Trent in 1966, and today he holds the prestigious Killam Memorial Chair in Ecology at the University of Alberta. David is recognized as one of the world's leading limnologists specializing in the study of human effects on freshwater ecosystems. To carry on in the spirit of that work is the inaugural holder of the David Schindler Endowed Professorship in Aquatic Science at Trent, Dr. Paul Frost. And Dr. Frost has studied a diverse range of topics in aquatic science, from zooplankton in Lake Erie to light penetration in forested streams. He completed his PhD at Arizona State, and he conducted postdoctoral research on nutrients in stream ecosystems. As the first David Schindler professor, Dr. Frost will teach and conduct research on the ecology of lakes and streams as a member of Trent's biology department. Dr. Frost has also recently been awarded the Humboldt Fellowship for Experienced Researchers by the Alexander von Humboldt Foundation in Germany. Please welcome Dr. Paul Frost.
No, that's okay. Okay, thank you very much for coming tonight, and thank you, President Franklin. Thank you for everybody that's helped me get to this point, and for the university creating this endowed professorship. I feel quite honored to be the first David Schindler endowed professor, and I hope I do the professorship some sort of honor. So I'm not going to be talking about my research tonight, although I'd love to. I love a captive audience, and I'd love to talk to you about water fleas and nutrients. I thought what I'd do is talk about how the globe is changing and what it might mean for lakes in Ontario. So what I think is that we have to think outside of this box. When I say global change, a lot of people will think this means global warming and a changing climate. Well, global change in more of a bigger view involves a lot more. So I'll just give you some other aspects of global change. Global warming really is derived out of population growth, and I'll be talking about how the global population is changing and what that means for water. This also affects then land use. As we have a larger population, we have to have more land for people to live in, and we use more land for agriculture. This is massive amounts of land use change happening around the world, including in Ontario, if you haven't noticed. As more people live and use this land, we tend to want to use water, so we take water out of natural systems and we move it around. Massive changes in the distribution and movement of water, which humans are completely involved in. We also tend to overfish, and marine systems are facing a terrible crisis of overfishing. And I don't think that freshwater systems are necessarily immune to this. And since we've overfished our natural fisheries, we've now started finding ways to grow a lot of fish in the water. So this is contributing to global change. And during a lot of all of this, we're releasing a wide range of contaminants and pollutants. And if we didn't have enough already, we generate an entirely new list of novel chemicals every year. Somewhere between 50 to 100,000 new chemicals are generated in labs around the world every year. And we use those in a variety of industrial and commercial applications, and then they end up going into the environment. And on top of all of these other global change drivers are invasive species. So humans, through commerce and such, move goods and services around, which tends to move species also, and we certainly need to think about invasive species as a global change driver. Now, each of these has unique causes and consequences on lake ecosystems, and that's what I'll be talking about. So first, I just thought we should think about the sort of larger context of how this works. This is a graph of the global population through time. And as you can see in the recent history, the last decades and 100 years or so, the number of people living in the world has exponentially gone up. But the amount of water, fresh water, is constant or actually declining. So this means there's more people sharing less water. So what you could do is, this is the population in billions of people, take that, some estimate of fresh water in the world, and divide it by the number of people living, and this is the kind of graph that you get, which is really kind of depressing. This is on a log scale, per capita water, millions of liters per person, and for most of the human history, we're around 1 million liters per person, and now, because of this population explosion, we're down to around 40,000 liters per person, depending on how you calculate fresh water, if you include groundwater or such. Just for context, the volume of Olympic swimming pool is around 2.5 million liters. So this is really not very much water per person. Now you might be sitting there and thinking, oh, but in Canada, we don't have this problem. We have plenty of water. Canada holds, depending on whose estimate you use, about 10% of the fresh water in the world, and we don't have 10% of the people living here, so we have a lot more water. In fact, you can see this on a map like this. This is the extremely uneven water distribution around the world. Places in the mid-latitudes, which have very arid systems, tend to have a lot of people, very low water supply, and in this graph, they actually call it catastrophically low. So if you're living somewhere like Saudi Arabia or Libya, you have water problems. And in Canada, you can see we're way up there. We have plenty of water. However, the same sort of problem of more people with a constant amount of water does actually translate into Canada. So this is some calculations I did where I took the total volume of the Kawartha Lakes, which, again, depending on which lakes you include, is around 600 cubic kilometers. And I took the population of the Peterborough region over the last 150 years, and you can see we started out around 317 million liters per person, and now we're down to around 10 million. So we each own more or less around four swimming pools of water in the Kawartha Lakes, which compared to what most people in the world have ownership of is pretty good. We're swimming in a lot of extra water. But this is not, I don't think we should look at this and think, wow, we have plenty of water. We don't have to worry about the water we're drinking. There's enough water there. This is more of an index of our use of water, because every person that lives in this area uses this water. We take the water out. We use it for drinking and bathing. We use it to water our lawns. We use it for commercial and industrial purposes. So as our population grows, there's more people using this constant amount of water, and the sum total of all those activities tend to accumulate. So what you end up with is something like this: more people living in the world and in Ontario, which is looks to be true. So this means less water per person through time. And unfortunately, wherever this accumulating population has occurred around the world, we see this, which is the degradation of aquatic ecosystems. So the rest of what I'm going to talk about is this the future of our lake? Are we going to go from lakes which are nice and clean and you'd like to go swimming in, to something where you'd rather not spend your afternoon? Is this what we're talking about? Is this what our lakes are going to look like? They have in the somewhat recent past. Some lakes in Ontario have looked like that, and we've made some progress. Are we going to go down that road again? So one way to think about this is to think about, well, how do lakes respond to global change, just in a general sort of academic sense? And I thought about, well, what do we know about aquatic systems in general that we've learned from our past experiences in the last 40 or 50 years? And so this is what I've sort of derived as a few commonalities for aquatic systems responding to global change drivers. The first one is that aquatic systems can have big responses to very small changes. And I'll show a good example of this. The second one is that these big responses are very diverse. So as a lake or a stream becomes impacted by human effects, you can have everything from changes in the physical properties of that system, to the oxygen concentrations in that system, to the concentrations of nutrients and the proliferation of algae, to the loss of important invertebrates in the changes in fish communities. So it's across the board, diverse responses. And the unfortunate and depressing part of this is a lot of times these changes are irreversible, or they take long periods of time to turn back. So here is a good example. I wouldn't feel right if I didn't mention Dave Schindler in my talk, so I thought this was a great example. This is actually Dave Schindler's experiment from the experimental lakes area. For those of you who are not familiar with this, this is Lake 226, which is located outside of Kenora, Ontario, and they put a curtain down the middle of the lake. On one side of the lake, they added carbon and nitrogen, and the other side of the lake, they added carbon, nitrogen, phosphorus. And this is a very dramatic picture of what happens if you add phosphorus into a lake. It turns super green, and you have algal blooms. So I started thinking about, well, how much phosphorus did it take for Dave Schindler to make this change? Was it a truckload of it? What was it? Like, how much of this did it take? And so I did some calculations, and it turns out all you need for the entire summer, so they added some every week, across the entire summer, this is the amount of phosphorus they added in the lake, which is 6 5-kilogram bags. So it's 30 kilograms of superphosphate, and there is a product, in case you're wanting to buy some of this, it's called superphosphate. It's available at your local Home Depot. You can just go on down and get your 30 kilograms, and you yourself could do this, from what I'm told. Small inputs, big change. Another good example of the responses of a system, which are really, and this is really well documented, is, excuse me if I'm not saying the name right, Lake Vuluwemer, and this is in the Netherlands. And I like this example because it illustrates some of the longer term aspects of global change. So in this lake, historically it was quite clear. It was sort of a shallow lake, and it had abundant submerged macrophytes, and that's just another way of saying there were a lot of weeds that grew in the lake. So in this clear water, so a lot of light came in the lake, and it let the weeds grow. Well, they started adding phosphorus to this lake, and it let the algae grow, and the algae grew quite fast, and they noticed that in the early 1970s, this excessive amount of phosphorus fueled this algal growth, and it changed from a clear water, this is what they call a clear water state, to a turbid state. And the change that this brought about was that the plants disappeared. So instead of having clear water with a lot of plants, now you have a turbid water with a lot of algae and no plants. So they, we'll just reduce the phosphorus and we'll push it back to the high plant state. So this is shows what happened, and this is from Nature, a paper in Nature from 2001. And what this shows is the fraction of the lake surface covered by the vegetation, and how it changed with the total amount of phosphorus. So the red dots show what was happening in the 60s and into the early 70s. As they added phosphorus into the system, the concentration of phosphorus in the lake went up, and the algal bloomed, and the fraction of the lake that was covered by vegetation went from around 40% of the lake down to no, you couldn't find a weed in the lake. They were all gone. So they said, well, okay, fine, we'll start reducing the phosphorus, and you can follow the arrow back. They started reducing the phosphorus, and by the mid-1980s, they had reduced the phosphorus back to where it was in the 60s, but there were still no plants there. The algae was still dominating, and there were no plants coming back. They had to reduce the phosphorus even further to well below what it was previously for the plants to start coming back. Now, when you see this, it's to me this is profound, because it shows there's sort of a threshold where when they went past a certain amount of phosphorus in the lake, it switched systems. It switched from a plant-dominated to an algae-dominated system. And they couldn't actually get it back to that system without a considerable amount of effort. And the other thing, which is really easy to miss on this, is that we're talking decades here. So these changes started in the 1960s, and it's not until the 1990s that the fruits of their labors, 20 years later, did the lake really respond. So my other point with this kind of graph is try explaining this to someone who's lived on the lake for 10 years, what's happening. Because they've only seen the lake for a short time period. They don't know what happened 30 years ago. They don't remember what the lake used to be. There's nonlinear threshold behavior with considerable lag times built in. That's the academic speak. It's very complicated and dynamic. Small change, small inputs, big change, and hard to turn around. So those are some characteristics of global change and how they're like to affect the health of our lakes. I next thought, well, let's just think through this. What would be issues for Ontario? What are if you really pressed me, what are 3 things I can say are of high probability for change? What will happen in the coming decades in Ontario? And I don't think you really need to be an expert to come up with this list. I don't think this is surprising, but it's more depressing than anything. So this is the doom and gloom part of the talk. Clearly, Ontario is continuing to develop and change the land in conjunction with massive population growth. And you have aquatic systems like this with increasing numbers and densities of houses around their edges. This is happening. I'll show you some examples. It continues to happen. We're building new developments. Toronto is getting larger. I'll show you that. What comes along with this are changes in the way that water flows through the system, changes in the type of water, the quantity of the water, the quality of the water. We have stormwater now, which is filtered through urban areas. We have new sources of sewage, which we have to deal with. There's pets that live in a lot of these houses, and 2 large dogs actually produce a lot of waste. There's novel contaminants, stuff like preservatives that they add to the building materials, which then leach into the stormwater and get moved into these systems. People add fertilizers to the lawn, It goes on and on and on. And it's coupled to the removal of natural areas, areas where the water would have spent time and been processed. So this water is now moving more rapidly through systems and ending up in our aquatic systems. To show you the sort of extent of human development, to give you a little bit of perspective on this, I went to my favorite Google Maps. And since we're at Trent, but could put Peterborough here for your perspective. I like this view, which is that really it has more, Peterborough is more the center of the world than Toronto. Here we go. We have the Greater Toronto Area, and if you just look at the City of Toronto's official plan, this isn't the realistic, there's more generous estimates of where the population of Toronto is headed, but they're saying that Toronto will have 7.5 million people by 2030, and that we're probably already around 6.2 now. And you can see this development. I put a little dotted line around it. Anywhere the map is slightly gray is urban area. And I don't include the urban areas growing in other places like Barrie and Waterloo and London, Kirchener. All of these areas are seeing massive amounts of development. Well, if you live in Toronto, you want to get away for the weekend, so there's some good options. You can drive 3 or 4 hours away. It's really quite convenient. Toronto's a marvelous place to live, and it's great opportunities for cottage living. And there is a vast area of beautiful lakes, and this is what I have been starting to call ex-urban development. So coincident with urban development and land use change in our urban centers, we are having considerable amounts of land use change in the more natural areas of southern Ontario. You can see this. You can zoom in on a little lake like this one. I didn't search around for this lake. I just kind of, well, it wouldn't have made a good story if I picked a lake that didn't have any cottages. So I did find one that had some cottages on it. And this isn't abnormal for a cottage lake. You can see the distinctive features here, which is the road all the way around and some clearings. I figured out that we could get an estimate of the number of cottages by counting the dots on the shoreline, which I identify as docks. So there's about 103 docks around this lake. And I don't have the numbers, but I suspect this isn't isolated to Misquabi Lake. So we have massive changes in population and the way that we're using the land. And we will also have new invasive species to accompany that change. We already have species here that weren't here before, like the spiny water flea, Bithostrethes, and the zebra mussels. And they have, in some ways, changed our systems irreversibly. Other species are on their way. The round goby is somewhere in the Otonabee River, working its way towards the Kawartha Lakes. It's just a matter of time. And there's no reason to believe that this won't continue. There is a large number of species in the world just waiting to come to live in our nice Ontario lakes. The Asian carp is one of them. There's other, and even more warm water species, and this links into the next driver that I'll talk about. Because as we go into the future, our lakes are likely physically going to be quite different, which might make them more amenable to invasive species. I haven't thought a lot about global warming. I've always kind of thought, well, nutrients and invasive species and other drivers will be much more important. But when you really start thinking about it and you look at, there's some really great websites by the government that allow you to look at models to say what's going to happen to the local climate right here in Peterborough. And you can see different mathematical models and different assumptions. You can see it. But generally, what they're predicting is that in the next 50 years, we'll have 3 to 7 degrees of warmer in the winters and the equivalent in the summer. It's going to be warmer. We're going to have warmer temperatures here. It's a little bit harder to predict the precipitation. Those models are a little less sure. it looks like we'll probably have the same amount of precipitation, but because it's warmer, we'll actually probably have a little bit less water, more evaporation. What I think is really profound is you add this warmer temperature, the growing season in southern Ontario is going to be probably a month or two longer. So you'll be able to plant your garden in late March probably, and you'll be able to grow tomatoes until, I don't know, middle of September, early October. I can't see how that's not going to affect the lake ecosystems. Aquatic plants like to start growing when the ice comes off, and they tend to reach a peak in early July, late June. We can expect that to be moved back by at least a month. And there's other aspects which will likely change the lakes, declines in the ice cover and ice duration. I just put this oil sands thing up. This looks to me like something that would be from history, right? No, this is a book that you can buy now. Believe it or not, there is a global market waiting for our oil. And so I don't see any change on that. We're not going to change this. This is something that's coming. We don't have any resolve to work on that, especially when we're still exploring the global market potential of our oil. So this is the point where it's somewhat uncertain to say, well, how's the global climate going to change, or what's going to happen with land use? I can more or less make a pretty strong, certain prediction that that's going to happen. It becomes a little less certain when you say, well, how is this going to affect the aquatic systems? So this is really when you have to look in the crystal ball and say, well, I'm just going to pull a few things out. If we put this all together, what should we expect? Well, we should expect more frequent and severe algal blooms. We're going to have more nutrients coming into the lakes from more diffuse sources. It's going to be increasingly difficult to control them. We're going to have a longer growing season with warmer lakes. It's going to proliferate. This is great conditions for algae to grow. We're likely to have more frequent and severe algal blooms. We're likely to lose native biodiversity as the lakes warm. As we experience this changing climate, we're going to see southern species coming in, and that's going to move our species more north. So we'll lose the diversity that we're more used to. I think we'll be faced with more and different types of water treatment that as we increase the amount of contaminants and we have more algal blooms, we're going to have to be much more careful with the water that we're using. So I think that's definitely coming. As we change the hydrological cycles and it becomes drier, we're going to have greater water fluctuations, and we're going to see it much harder to maintain the current levels of water that we're used to, not only in terms of lakes, but also streams. We're likely to see more temporary streams and streams that are ephemeral that come and go. And all of this together means that we're likely to have substantial changes in the services and functions provided by these aquatic systems. Stuff like the recreational quality, the number of fishing days, the enjoyability from taking your boat around the lake, the quality of the drinking water, it goes on and on and on. So I don't want to entirely end on a pessimistic note, so I'll just stop with a few pictures of my family enjoying water, and so this is really what it's all about. I was at this event last month for the Trent Severn Waterways, and President Simons was there, and he says it's all about water, and I really do think it is all about water, and trying to somehow protect the water and address these issues so that the kids will have something in the future, and their kids will have something. And with that, I thank you for listening to my Schindler lecture, and I'll end there. Thanks.
Thank you, Paul. Good evening. I'm the old chair of biology. I use that term deliberately. And I think one of the things that everyone in the room should realize is that the Schindler professorship in aquatic biology has another main function, which you've heard tonight, and that's teaching. Biology across the country, and especially at Trent, is booming. Our first-year class has now increased in 1 year from 360 to 430. We exceed the Wenjack Theatre And so a year ago, I had nice brown hair. And, we are under pressure, and unless we have positions like the Schindler professorships coming, the undergraduates will not get a quality of education. So it's really critical that these positions come to Trent to maintain the high quality of education that Trent delivers. And biology is right now under particular pressure for that. So this is a public welcome of Paul. He's been busy as a bee for actually quite a while, but he's made quite an impact, as you can see, in research and teaching in the department. So we're going to have a panel discussion in a minute to follow up on the nice introduction that Paul has given us, and I'll introduce the panelists. We've got a prestigious group, and I think we're going to have a really lively discussion. So the process will be I'll introduce the panelists, and one by one you will assume your positions. So the first panelist that I'll introduce is John Gunn. John Gunn gave the biology department a seminar today, so I've introduced him twice, so we'll introduce him twice. John Gunn was a Ministry of Natural Resources scientist, and then obtained a Canada Research Chair, and now is a faculty member at Laurentian University. And I sort of emphasize that because of the unique relationship of M&R to Trent, and in many ways I think John represents a model of that in another university. John talked about the kind of experiments that he's been doing on lakes, which are similar to the ones that Paul described by Schindler. Just massive experiments in lakes trying to tease apart some of the effects of warming. I've not met John much, but when I was at McMaster, my colleagues talked about him all the time, so I think I know him quite well, and he's a very important person in the Canadian fish research community. So welcome, John. Thank you. So the next panelist, Mary Smith. She's the reeve of Smith, Ennismore, Lakefield townships. She's been involved in a large number of community activities, boards and committees, and she's been a strong advocate for environmental issues, and been serving on Trent Conservation Coalition, Drinking Water Source Protection Committee. So she brings a lot of expertise to this panel. So Terry Rees, Executive Director of the Federation of Ontario Cottages Associations. It represents over 550 associations across Ontario. He's had experience in environmental policy and management and sustainable business practices. And he's been involved in water and energy management, mining, minerals, and the petrochemical industry. So welcome, Terry. So the fourth panelist is Paul Frost, who you know well, so I'm not going to talk much about Paul. So handling this group of experts will be Mike Barrell. Mike Barrell's a former chair of the biology department, and I want you to contrast old chair and former chair. Mike, I was talking to him today, has a twinkle in his eye. He smiles a lot. I look in the mirror, see bloodshot eyes, and I can't see a twinkle. So I'm looking forward to becoming a former chair like Michael. Michael has extreme expertise in water environmental issues. He has worked in an area close to my heart, marine ecosystems and their degradation. He's also worked on a lot of fresh water system, particularly amphibia, and I entrusted him both with my daughter and my daughter-in-law in terms of doing theses in his lab. So they turned out okay. So thank you, Michael. The panel is yours.
Well, good evening. For the next hour, we get to explore the ideas of our panel. It's a very diverse panel with different points of view. The way this is going to be organized is that for the first half hour, I get to ask them some questions and maybe a couple rounds of questions, so you get a sense of their points of view from their various backgrounds. And then we'll open it up to your questions for the final half hour. And I'd like to start by asking John Gunn, you work in the north, well, sorry Sheila, not really the north. You work in southern Ontario, but we call it northern Ontario. And perhaps you could comment on to what extent you see the same drivers at play as Paul's been talking about.
I actually will talk about the real north, because I just spent a year on the Premier's Council in the far north in advance of the passing of Bill 191, the Far North Act, and some of you may be listening, as we do in the mining areas of Sudbury, almost daily about Ring of Fire and such. So I come thinking about these problems as an optimist, as a son of an ancient mother who's still alive and who is Scottish and likes to talk about suffering builds character and doesn't produce any waste and never has, and knew Victory Gardens and knows how to solve these problems. And I think I know how to solve these problems. And it's simply to eliminate waste. There is no need for managing phosphorus in the ways that we're thinking about around this table. We simply have no discharge rules where no phosphorus is allowed. Any phosphorus brought into a watershed has to be taken out of the watershed in total. No discharge on septic tanks. That we cap energy, not energy rates, we allow those to go as high as they may go. We allow oil prices to go as high as that will go. We cap the use of oil and the use of electricity in Ontario. And we let the competitive forces run their course at that point. As we did in the oil crisis of '73, where Toyota and Honda were given advantages in North America that they would never have got otherwise. We let technology solve some big problems, and we need creative policy, politicians, and that have to insist that waste be eliminated. Waste is equivalent to pollution. If we take all of the pollution and problems we think of, if you convert them into British thermal units of energy, you can start there and just eliminate energy use or control it. And most of the problems have to be dealt with, whether it's nuclear power plants or windmills or... So I think we really need to cap energy use in Ontario and push the system. As we had the fun of, I lived through Sudbury. I enjoy, I don't know why you don't have a tall smokestack in this town. With these one-way streets, I can never find my way anywhere. If you had a tall smokestack, everybody could find where you live. It's hopeless. You don't have a big cow, or you don't have any big thing. Northern Ontario would have a big thing. But Northern Ontario has a global responsibility, and as Canadians we have responsibilities that are far bigger than our petty issues around our docks and our cottages. We are the center of water science in the world. We want to maintain that role. Canadian Journal of Fisheries and Aquatic Science is the highest impact journal in the world. For some reason, government allowed it to leave the public sector this year. It was a gift to all Canadians, and this year it becomes private. You can't get your free subscription to it by going on the internet. But we are a Canadian water nation, and David Schindler is a product of it, and Paul Frost is a product of it. And we export that technology to manage the world's water. We don't just sit here in the Muskokas managing some little tiny area. I just got off the far north panel, and we sit, this is a marine province. 60% or 57% of the province drains to the Arctic Ocean. Tiny bit goes out the St. Lawrence River, small streams around here. Nothing to talk about. The big issue is the Hudson Bay Lowlands contain, the far north of Ontario, if you know where it is, it's north of 51 latitude, is beyond the end of roads, it's beyond the end of transmission lines, it has a population of 24,000 First Nations people in 36 communities. And the news is filled with the fact that for mineral security, mainly in China, we're about to process one of the largest mineral resources on Earth, the Ring of Fire chromite deposit, for hardening steel for armaments. You know, what have we learned in the Middle East this week is nations and communities and citizens don't like to be managed for their resources to keep our cottages warm in the Muskokas. They don't like it. So water is a global issue, and we're the ones that are sitting with the knowledge and the science and the universities to deal with it. And the North, I wasn't going to say anything controversial tonight, I hope I haven't yet. All right. The North is a fantastic thing, and we have to stand behind the First Nations communities that are blockading that development. Because there's 36 of those communities, and there's not only one of them last year didn't have a bottled water advisory. They don't have any drinking water, and they got $1 trillion chromite deposit in their yard. Can't they get, you know, the diesel oil out of the ground at Aquatic and let the kids go back to school? Can't we get drinking water for 24,000 people? That's like some tiny town around here. And they got trillions of dollars worth of mineral resources. Don't let Ontario deny them access to the resources from that, because and what are they guarding? They're guarding, on your behalf, our behalf, the refrigerator of the world. The second largest wetland in the northern hemisphere, third largest in the world, sits in the Hudson Bay Lowlands, constantly absorbing CO2 that allow us to run our SUVs and buy cheap things at Walmart, plastic things that they produce with lots of oil and gas from the Middle East, to buy cheap products at Walmart so that we can get them at the dollar store. Whoever could buy a hammer for $1 before? Now you can. That is the argument that the First Nations communities are guarding the wetland that's absorbing our carbon dioxide. And it is managed and only exists in Ontario. You wonder why you get that cold spot. In the weather every day, there's this thing that comes down in the middle of Ontario. In my area, it's always cold and you guys are warm. That's because we've got a frozen cold waters ice cube stuck in the north. James Bay is nearly a freshwater sea. Freshwater freezes when marine doesn't. We have the most southerly frozen sea stuck in the middle of Ontario, and it holds together by the cold effect of that sea all of the storage of our carbon and all of the mercury that comes across the North Pole and is stored there. And we're just about to play around with that. And I don't think this audience is going to let that happen. I think you're going to stand with the First Nations communities, and you're going to insist that your premier allow electrical prices to go up high and oil prices to go high, so that innovation can bring them all back down again. If you read Michael Porter's Harvard University writings on how innovative policies can bring about great productive change. Look what happened to the acid rain program. That was solved, and to great benefits of individuals and to the health of kids. We went after an acid rain problem. We solved, or partially solved, an asthma problem in southern Ontario.
John, I got to cut you off.
Thank you.
Okay.
I think it's easy to solve these problems if we cap things.
That's part of the John Gunn I Have a Dream speech. It's a good dream. Paul talked about the image of the lakes as being a region of exurbia. And I'd like to ask Terry Rees, do you think we are heading into a time of too many cottages? Have we gone too far in development?
Thanks very much. And firstly, really privileged and humbled to be with the panel here. So I've hung around with enough scientists to know enough to get myself into trouble. But I think my answer would have to be, and I've learned this from some of the smartest scientists in our country, that it depends is my answer. Thank you. As we've seen, the imagery that's about water in Canada, if you Google Canada, if you talk about Canada, if you have a G8 summit or anything of the sort, it's all about lakes, canoes, children splashing in water. It's part of our culture, it's part of our existence, it's part of our history. We've done a lot of things to water over the years. John's had the experience of living in a neighborhood where we've got a lot of point sources, where we've got a lot of industry in the mining belt, something I've got a little bit of experience with. We've got a lot of impoundments in southern Ontario, alterations, diversions, things that we've done to water in the name of a whole bunch of higher purposes. So it depends, I guess, is really my answer, because it depends on what we think we want water for and what the purpose of it really is. If we want to canoe in it and have abundant wildlife and thriving clean water for a variety of purposes, then you have a different lens. Most of what we consider as our perspective on whether water is healthy or clean depends on what our intended purposes are. The US EPA in their National Water Quality Index suggests that about 2/3 of the assessed lakes that they've looked at are no longer suitable for their intended purpose. And you have to look in the definition about what that intended purpose is, because if you're using it for cooling water for a power plant or water skiing or swimming or drinking, you may have an entirely different, or even settling sediments or something, natural contaminants or otherwise, you have a different lens about whether your water is suitable for its intended purposes. We do know through the abundant science that's around, and not suggesting that we know all the answers, I think mostly no more questions is what I've discovered in dealing with my scientist colleagues, Dorset Research and elsewhere, is that all of our combined aggravation that we've piled onto water end up having long-term implications that we have to live with. We've got pathogens, we've got mercury, nutrients, organic enrichment, dissolved oxygen. But this is always a depressing conversation when we talk about this. I'd rather talk about the stuff that's about the positive things about water and what we can do about it. We know that through recent studies like I have to do a plug for the Biodiversity Council, which came out last year, most of the impacts to our natural biota, and that includes water resources, happen where there's a lot of us. And that's not just a cottage question. I am circling back to your cottage question. But we do a lot of things as humans that impact water, and that's roads, mineral extraction, forestry, just where we live. So there's a combination of human interests and activities that can impact water. I have also the good fortune of dealing with about 500 communities that live around water, a lot of beautiful lakes, including Muskoka Lakes and Mesquabi, by the way. It is about 100 cottages, and including some lakes, which are some of the oldest communities in Ontario, near Kenora, Lake of the Woods, where their water does flow, what I say, the wrong way, because I'm from southern Ontario, it all goes north. These are all west and north, in fact. These are long-standing communities and people that that have as their livelihood and as their life an existence around water, and have the benefit, unlike a lot of scientists, of having sometimes generations of experience on water bodies. Some of these problems, like in the Lake of the Woods, they've got blue-green algae problems that have persisted for hundreds of years that have some natural basis, but a lot of people, since we take so much through our human lenses, a lot of what we see and experience is really related to what our experience on the water. What we expect out of water and whether it's degraded is really is an intertwined question and answer, I guess. We do impact water every time we live around it, or play in it, or use it for any of our purposes. So I think that cottaging is and residential living around water has an impact on the water, partly on the water quality, partly on the composition of things that are in the water, the species that we bring, the nutrients that are there. But there's a whole lot of, the whole basket of things that John suggested related to water use, our transportation choices, and other things that impact our water. And we have a lot of choices that we can make that can deal with the combined stressors, which is reducing the natural capacity of our systems to assimilate the multiple aggravations that we put on the system as humans, but also to deal with the natural swings and dynamic nature of our climate. I'll wrap it up there because I think you're just about to wrap me up.
Okay, thanks. Mary Smith has 13 years of municipal experience and brings a more regional voice to this. I wonder, Mary, if you think that from your sense of municipal politics that we in this area are prepared for the kind of threats that are on the table here.
Thank you very much. I would say that we are preparing. Is this mic on? It's wonderful that this opportunity, this initiative has taken place, because I think there is a real hunger. I've spoken with many people on the doorstep in our community who live on the waterfront, and they are keen to do the right thing to preserve the health of our environment and our water quality, but they don't know what the right thing is necessarily. So I think we're on a huge learning curve as a community, but we're also in a major planning phase in our municipalities. We're in this city and county right now. We've initiated a sustainability planning process, and that's a process that all municipalities will have to go through, and I'm glad we're into it, in order to access the federal gas tax money. So there's always a good reason put in front of municipalities to get the job done, but it is the right thing to do. The province has initiated the drinking water source protection planning process, and Terry and I both sit on that committee, and it's a committee for the Trent Conservation Coalition, and it's a science-based approach. All these documents are basically the assessment report that's been done. It's a tremendous amount of data collection that's been done, and out of that science-based approach, we will develop policies for best practices to protect surface water intakes and wellhead protection zones, so to protect the quality and the quantity of drinking water for the future in the Trent Conservation Coalition area. There's another whole set for the Ganaraska watershed. This is just the Trent watershed. As well, we're seeing the Oak Ridges Moraine Act in place now, and Conservation Plan, and the Greenbelt Act, and these are provincial tools that are there to assist in protecting the natural areas and restricting urban sprawl, and they do have a positive impact as well on water quality. The Trent Severn Waterways initiating a planners forum. We, for years, have people on one side of the lake who say, why is it the people on the other side of the lake have different zoning bylaws than we do, and different rules to play by? And we have Stony Lake, 4 different municipalities, for example. So we're trying to harmonize and have the right zoning bylaws for our system. The local municipal plans that we all use, they're our guiding planning document, are continuously being updated with the new provincial policy statements. And now we have the requirement for setback for development from the water, which makes a huge difference, the 30-meter setback. In our township, we have been a leader in the county. We've now got a new site plan bylaw where it expects that residential development with water frontage will go through a site plan process, so we can control the removal of trees and other vegetation changes that might be tempted to be done by a developer and not following necessarily the appropriate process to keep the buffer zone in place around the lake edge and the shoreline. And our conservation authorities are doing great work to protecting these shorelines and the floodplains, and a lot of public education as well. We've got a lot of NGOs in the area. Green Up is a good example, that are providing educational programs and initiatives. We are improving our knowledge, and constantly there are best practices being put in place around renewing our infrastructure on wastewater treatment and water treatment facilities. And as well, the septic system designs are improving all the time and being monitored even more closely by, in our area, the public health unit. We mandate from the municipality, we contract for them to do that function. And I would say that we, as well as municipalities, are working with the lakes, the cottage associations. Some of them have initiated lake planning processes, and the municipalities are trying to be as supportive as we can be in that process. So it's an exciting time. There's a lot of work to be done, and I think that one of the issues is the capacity of local municipalities. We've got some very small municipalities, and we have some larger ones, and having the staff capacity to be able to be involved in all these planning processes is certainly it's a financial challenge.
Thank you. This is all sounding strangely upbeat.
It is. It's all easy.
So in hopes of countering that a tiny bit, Paul, would you like to comment a little specifically on who you think the worst offenders in terms of the threats are in this region?
Well, that's a great question. I did actually do some homework with this question. I started thinking about how do we use our water, and the answer, it was quite surprising to me. If you just look at the average Canadian's water budget, how much water per person is used for different things, you would be surprised by what we use our water for. A large proportion of the water that the average Canadian uses, and Canadians use a lot of water compared to other places in the world. We rank right behind the US in terms of the amount of water used per person per day. And a large proportion, and this is particularly true in Ontario, a large proportion of our water usage is involved with thermoelectric power plants. So in other words, what that means is you can buy a low flow shower head and you can flush the toilet less often. You can water your yard less, but if you continue to use your air conditioning every hot day and you still run all of your appliances all the time, that electrical use is actually generating a huge water footprint that you are not thinking about. The other way to think about that is if you were serious about reducing your water input, you would reduce the amount of electricity that you're using. We would cap our electrical use. We would cap our energy use. We would find ways to price water in a way that made the use of the water in these industrial processes honest. So it shouldn't be that water is cheap and free for a power plant to use, because it's not. So that's a subsidy on our electrical production that's being transferred into the water pollution. And in this case, you might think, oh, well, what kind of pollution can they be producing? It's actually thermal pollution, and it's well documented that we're adding considerable amounts of heat into the Great Lakes. That said, I don't think anybody can get off the hook by just saying, oh, it's a power plant issue, because we use water in a lot of different ways, and we add a lot of waste to waters. And my background is in nutrient biogeochemistry, meaning that I tend to think about how nutrients like carbon, nitrogen, phosphorus move around the environment. My background is to think about what things are made out of. So how much phosphorus is in this thing, or how much phosphorus is in that. And this allows you to sort of look around and say, where are these nutrients that go into the lakes that fuel algal blooms? Where do they come from? And there are some low-hanging fruits that I think we really should seriously consider. We have an odd approach in southern Ontario, and this is common in North America in most places, which is we allow these materials to be added to the water, and then we spend a lot of money removing them. It makes much more sense just to not put them there in the first place. It's far cheaper to keep something out than to, after it gets in, to try, and it's usually not very effective, to try to remove it. So, for example, we build new developments and we embed stormwater management ponds in these developments. And we have some work going on in my lab in urban ponds, so I've been thinking about this, and I look at this water, and it tends to be very nutrient rich. And then you start thinking, where does this nutrients come from? Well, it comes from the stormwater. Where does the stormwater come from? It comes off of people's lawns. Where do the nutrients get into the stormwater off of people's lawns? Well, it's fertilizers and pet waste. And then you start thinking, well, wait a minute, why are we adding fertilizers to our lawns? It's very cheap to go to Home Depot or the local garden store and buy these extremely powerful plant growth additives that also fertilize our aquatic systems. It's very cheap, but the cost of removing those once they get into the water is extremely high. It's very expensive to build an urban stormwater pond. Costs about $500,000, and that doesn't include the maintenance cost. If you multiply that by the 500 that Toronto owns, that actually turns out to be a substantial cost in terms of infrastructure. And they're very ineffective in what they do. So that's really unwise for us to add something sort of into the environment and then use ineffective and expensive means to remove it. So in terms of southern Ontario, I think, there's low-hanging fruits. We should really cut down on our waste. We should look for places where we're adding wastes, including nutrients, without really thinking about it, and try to keep that out. It's quite easy. Just don't sell the fertilizers. You just move it to a place where it's hard for people to buy. And believe it or not, other places are doing this already. You just can't buy them in Minnesota anymore.
Well, let's hear it from Minnesota.
Absolutely.
I'm going to open it up to you all, and if you don't have questions, I have a few, I must admit. But this is an opportunity for you to ask any of the panelists, or all of them, whatever's on your mind. Yes?
I guess it's just a clarifying question. First, but I'm new to Canada, so I'm a little confused about the last thing you said. Wasn't it the case that charging more for the cheap fertilizer at Home Depot for a month or two there was in place in Ontario, or am I misunderstanding?
I don't know about that. I've looked into this, and as far as I know, you can still buy all the fertilizer you want.
Oh, no.
Are there restrictions? No, you can go buy a truckload if you want. Add it to your yard, no one will notice.
I've never bought any, so I don't know.
I have a colleague who worked on this problem in Minnesota, and he measured the amount of phosphorus in the average lawn, and he found that there was essentially a 5-year store of phosphorus in the lawn. So in other words, you stop fertilizing for 5 years and your lawn wouldn't care. That's the amount. And some people add, that was the average lawn. There's other people who add way more phosphorus, every couple of weeks just for good measure.
So much for weed man.
And in Quebec, our sister city and province, they simply count it all in some watersheds, that your groceries are part of the fertilizer process. So they don't allow septic tanks in the watershed. You bring it in, you take it out, and it's all in holding tanks. And it's your responsibility. You bought it, you take it home with you, just like you do it in provincial parks with glass and cans. It's a little messier to take it out than to buy it in the first place in groceries, but that's a simple kind of in and out process. And septic, and you know, I was on the Lake Simcoe panel, very creative, wonderful, committed group of people. Some of the solutions are expensive. A zero discharge sewage plant is expensive. But there are technologies where if the answer is you're not allowed to let it go, you have to find a way to keep it and take it home with you. So that, I think if Quebec can do it in their cottaging areas, there are solutions here.
Mary, you'd like to add?
I think it's a great idea. I think it's doable. We've seen it with the use of pesticides and herbicides. It used to be just common. You'd go, you'd buy them, you'd put them on the lawn, and through education and legislation, you can change people's thinking. And if fertilizers are added to that list as the thing we shouldn't be using, then I think I think there would be acceptance of that, and if the rationale is provided. And we had a no use of pesticides for cosmetic reasons in the city a few years back. That bylaw went in, and then our township of Smith Ennismore Lakefield did it, and then the province mandated it. So it's just a matter of time if the reasons.
Let's talk after.
Yeah.
Mike, just could I chat?
Sure.
I feel left out otherwise. Phosphorus gets a bad name because it tends to have some really egregious effects on the health of aquatic systems, especially when it's in abnormal amounts. And as Paul pointed out, it can push us over the tipping point. But it's also a terribly important part of the important nutrient because it's of its value for agriculture and that sort of thing. Another really important element is lead, which I know a little bit about, and you die if you breathe it, so you shouldn't put it in gasoline. And so when they banned the use of lead in gasoline, the incidence of lead poisoning in the United States and Canada went to almost zero, except in urban city housing. So there's certainly, without picking on a certain element of the periodic table, I think there's some, again, it's a lot about decisions and how we use all of our technology and the decisions that we have in front of us. Phosphorus is only a problem when it's in a place that will run into the water, which is where, John? Everywhere, right? Pretty well.
There's no septic tank that keeps it on land. There's no system that prevents it from making it to the water.
Okay. Yes.
This is a question for Terry. Okay. The talk is the state of our water. Now, we talked about how the quality of our water in the Kawaka is like, we want the quality to be better than it is now, and we want to keep it as pristine as possible. Yet, I've heard, like I've actually come across students from other countries that actually look into an autonomy, even on the worst day, and say, wow, if this water was in our country, this is like, we would be swimming in it, we would be drinking it, we would be using it. Now, can you comment on like the differences between the standard and the global scale? And can each of you, the panel members, talk about, do you feel that we have an obligation to actually help other countries improve the water? Because the system itself, even though we call it our lakes, it's not a closed system. Globally, everything is connected.
Thanks. I think I agree. We have a tremendous asset, and we're blessed with the water we've got here. And despite ourselves, Mother Nature's terribly resilient, and we've got great aquatic resources here. Certainly, if you look anywhere else in the world, they've got a whole different set of circumstances that they look at water through. In the United States, they have a lot of brilliant water scientists, and they treat water a lot differently. They don't have the abundance of natural systems. This isn't picking. This is an anti-U.S. thing, by the way. But but they manage some of their impoundments and a stormwater pond like Paul would be talking about, and it's their lake, and it may be pretty soupy, but they spend a lot of time and energy managing for something that's never going to look as good as our Otonabee River in terms of clarity and phosphorus levels and that sort of a thing. We've certainly worked with some folks from the southern states that came up to look at some aquatic plant issues that we had in the Kawarthas, and they were perplexed what our problem was, because, as you say, they don't think the problem, the grievous problem that we had, was even a problem, and they wished they had that kind of water. I think the quote was something like, "Our water quality is when you don't know whether you should swim in it or plant corn." So when you have water clarity like we've got, which, where light's getting down 3 and 4 meters, and a lot of lakes, and maybe less so on less nutrient-rich lakes, I think we are obliged to look after what is really a special resource.
Anybody else want to?
I would just say from a sort of science standpoint, if we look at the Kawartha Lakes, which is where I have most experience in the Peterborough area, they fall into the good water quality. So I don't want to come off as saying we have massive water quality problems now. And I want to, my feeling is this is likely the fruits of past efforts to clean the lakes, because you look sort of into the history of the systems, they were more algal rich and more polluted in the past. So I would say, well, wow, we've made a lot of progress. And when I went out onto Pigeon Lake the first time, I thought, wow, this is a lot cleaner than I thought it was. The clarity is a lot higher. We have less nutrients than I thought would be here. But, and this is the big but, which is I think that we can't sort of fall asleep at the wheel here. We have to realize that the lakes easily could go back to where they were at. And so we need to look into the future and say, what's changing? It's not that we're not good now, but we easily could be in a bad situation. And that's real.
I'll just give one little story. I spent a month in this last year in China, in Wuhan University. It's a tiny town of 12 million. You may not have heard of it. But there's 1 million university students in Wuhan and 28 universities. And they call themselves the City of Lakes. And Sudbury calls itself the City of Lakes. I thought I'd go see that city. It's in one sense, it's a real tragedy. You can barely walk on the water. And, you can walk on the water, I think, on most days, often on dead fish. But it's impressive, encouraging too, is to see the reuse of water in polyculture. That the old idea that water has many, many uses. That the chicken and the pig and the carp and rice all growing in the same pond, and now they've added floating rafts of spinach on top of the same water, so that 5 or 6 different crops come off that one. That is the kind of technologies of minimizing use, because there is a country very similar to us that has a cold climate, you have to drive places, and it's winter, and you need a lot of resources, and it's Sweden. And they live on 1/3 of the water we use in cottage country there. And of course, the Swedish 60-year-old man is considered an icon of health and looks beautiful, and we don't. And why is that? Is that because they use less water? And at Wuhan Agricultural University, I noticed a strange thing, that in a small number of 40,000 students, they issue the water for the day to each student, and that student carries the water with them. I wrote an article about these giant thermoses that are in front of the classrooms all over the campus. And I couldn't figure out for the longest time, what are these thermoses littering the... Well, the steam plant issues clean water to those 40,000 before sunrise. And that's the water they use all day long for drinking water, brushing teeth, and they go back to the steam plant at night to get water again for the next day. I was going to get our president to issue this idea to how many swimming pools of water would our students with their long hair require to look at as immaculately clean and productive and healthy as these kids did. It was about 10 liters. And that was water use exemplified, what Asian countries and Scandinavian countries can teach us about how to use water when it's valuable. If it's not valuable, and we argue about little things like the price of sewage discharges, we'll never do anything about it because it's not worth anything to us compared to a theater ticket.
Rob?
I'm just wondering whether the panel could comment on a little news story that I read today in the Globe. An example of unintended consequences, I guess, that Los Angeles has gone very heavily into encouraging people to use low-flow toilets. And the consequence is their sewage system is plugging up because there isn't enough flow.
Well, we have people in the room with more expertise managing the wastewater system in our community, and I'd love to have Chris Norman speak, who works for Peterborough Utilities here. Basically, it is a complication. We've heard that, and that's where the technology has to be. Innovation is a big word here. It is a word that we've got to be continuously thinking about innovation, and that's where I think we're poised to be, because we have this challenge. We can develop innovative ways to reduce our water use and deal with the challenges. And I don't know whether we want to hear from our expert in wastewater in the audience, but it's true. It is a challenge. For every action, there's a reaction.
Good evening. Quite a few of us in this room are involved in lake management planning. And back to John's comment about septic, it's kind of a mundane topic, but through our studies, and I work in the core of the Lakes region, we know where the sources of nutrients and contaminants are coming from. And we know in some of our shallower lakes like Scugog, Sturgeon, that 10 to 15% of some of those nutrients, phosphorus in particular, coming from septics on shorelines. And we've gone out in some cases in some of these lakes, and we've met with every property owner, on these shoreline properties, like Scugog, 1,600 of them. We've changed attitudes, and they'll admit that they know that they're causing a problem. But they have old systems, they have old properties, and their issue is they cannot afford to embrace new technologies that are available, whether it's holding tanks or moving to communal treatment systems. So I don't know if this is a fair question, but a lot of municipalities are looking at this. And the challenge is financial. And I guess my question is it incumbent upon government to provide incentives or provide some financial support to deal with these systems that we know are causing problems? As property owners are saying we can't afford it.
It's going to be mine.
I wasn't looking at you, Mary, or you, John.
You want to go ahead?
Well,
give me a minute.
Well, I think we just have to stop it, and for a while let some things slide that we can't afford to have polluters on lakes. If we can't have bylaws that say all septic tanks have to be pumped out once a year and they're enforced, then when properties are in violation, we have to turn the water off.
Do you want to try?
Certainly, and we've had these chats at the Drinking Water Source Protection Committee meetings. The province ultimately is looking at a septic system reinspection program regulation down the line. We're not there yet. They're concerned about the intake protection zones, the wellhead protection zones for now. That's the immediate concern. But they do want to, that's the impression we get, come forward with some regulation around how people best manage their systems. Now, I know the challenge is not just the systems that are being put in place or that are there, but those that shouldn't even be on septic systems. And I really feel that the value, your value in your home increases if you put out the money to hook up to a municipal water system and wastewater system. You're going to increase the value of your equity in your home by that much. So I think it's an economic decision that people have to make, and ultimately I think that's where they'll go, because the value of your home just won't be there if people won't want to buy it if it's causing a pollution issue, and you'll have to fix it.
Do you wish to comment?
Sure. There's about 1 million on-site wastewater systems in the province. There's lots of them. Lots of us don't live in cities. And we make choices every day about things that are important to us, and we deal a lot with our presence on the landscape and decide whether, how much natural area to protect and how many roads we need and how many factories we should have and how many people ought to live and where they ought to live. And Rob knows that a lot of the solution's going to be about changing a lot of what we each do in our behaviors and stewarding our environments. Then that means maintaining those systems, which generally do a fairly good job of dealing with pathogens, not so much with nutrients in the long term. We do have to decide whether we want to sterilize parts of the province and just not have any human influence, which is one option. Just put a big gate across, I guess it used to be Steeles, but now it'd be Highway 7. And just keep everyone living south of there, because most of those water systems, apologize to the people in the Ganaraska who still have some cold water streams, but keeping everyone away from the water's edge. But we do have a fairly rural history in Ontario. We've got a lot of farm communities that are, including our own, that are based in and around lakes, and we've got certainly residential areas and cottage communities that are, and waterfront communities that are based around water. So we do have to decide how we're going to find a place to live and do it in a low impact way. So I think that from a clean water perspective, in the Clean Water Act in Ontario, as Mary said, there's the priority, or the choice has been that for something that's going to pose an extraordinary risk that someone's decided is 100 meters, for instance, from a municipal drinking source, they won't allow a certain risk to happen, and that's a dry cleaner or a septic system, for instance. Beyond that, I think the money, the political appetite, and the fact that all these problems are slightly complicated, it's all about balance. And I think in the case of the Clean Water Act, they've decided that septic systems are not welcome, again, proximate to a water source. In the case of Lake Simcoe, that's got a terrible phosphorus problem. They've said if you're going to live there and have on-site systems, you're going to have some kind of tertiary treatment, so you can't have a traditional system. So those are the kind of priorities that we have to set as a community and as a society, that if we've got precious resources, we do what we can, where we can, within our means to protect them.
Hi. This is a question for Paul. What is the effects of road salt on our water systems, and what are we doing to manage it?
Isn't that one of your sons, Paul?
No, that's not one of my sons.
Set up question, is it?
It's one of the young scientists that's been working in my lab partly. So it's always great to sort of start the science process early, and eventually, you have good grad students. So this is yes, thanks. The effects of road salt on aquatic systems. We have a road salt addiction in Ontario, which I understand goes back a long time. We don't want to have ice on our roads because it makes it unsafe to drive, and that's quite understandable. But it seems like we add too much road salt in unwise ways, and we should think about that, because this salt is moving into wetlands and into streams, and it's accumulating in lakes. And we are seeing some localized areas, very high salt concentrations. Worst case scenario is the ponds that drain the 401 in the Don Valley, far saltier than the ocean now. You won't have anything live there except some assortment of microorganisms and algae. I like algae, but this is probably not what we want. The concentrations of the road salt components, chloride and sodium, are going up in systems all across Ontario, and they can remove salt-tolerant species. Yeah.
Mary?
Well, I just came back from the Ontario Good Roads Association conference, and that's where they talk about road salt. And the municipal application of road salt has improved immensely. They have computerized systems now. Within a lot of municipalities have been able to upgrade to computerized systems that are regulated according to the temperature and the humidity and so on, and they disperse as little salt as they possibly can in the process to maintain the safety level that's required through the Ministry of Transportation regulations. Of course, again, it's that word balance, and liability is the other issue. But I think we could do a better job in Ontario of regulating the private sector, because, you know, government has to follow these rules, but I think there are a lot of small operators out there that maybe are applying far more than is necessary and need education and maybe some regulation around that, but education particularly. So it's a good point. Now, in our source protection areas, it is a threat to drinking water, and it's something that we'll be developing policies on as well. So there are certainly risks related to it.
Just to follow up, I heard rumors that studded snow tires might be on the table for Ontario.
I'm trying to remember, not being a road expert, but I think that they're pretty hard on the asphalt, if I remember correctly. That was the rationale, if there are any road experts in the audience here.
I was just saying, is it cheaper to fix the roads or to have our cars rust out?
That's where you have to do a business case, I think, in the end, don't you?
We're running out of time. We'll take one more question. Diane?
Okay. Mary, I was very taken with your comment on all the different levels of planning that are going on right now. So there isn't a plan per se, but at least there's 4 jurisdictional matters that you're dealing with when you're trying to look at regulation to protect the water system. And I am struck with a small municipality like the one in Lake Belgium that you're responsible for, and your comment that do we have enough resources, enough staff resources and professional staff and even volunteers and community members to even meaningfully participate in all of these processes. So there's sort of, you know, multiple levels of processes, a cost factor to that. And then there's knowledge and experience at universities and colleges. Funding is an excellent partner with us in a lot of the water issues we're dealing with. And how can the universities get that knowledge to the policymakers and the decision makers so that we actually make something happen? I think the angst that the local community members feel is that time is running out and they don't know how to participate.
No, it's a very good point, and I think this is a great beginning, and we need to continue the communication amongst our institutions and our levels of government. The provincial and federal levels are doing planning processes all the time. I agree, capacity, it takes money to have capacity, and it's, you know, you look at the provincial government, there have been cutbacks in ministries, and it's happening everywhere. Now, economies of scale can be created. We find we can create some partnerships that in municipalities do result in us not all having to reinvent the wheel. And so I think we're going to have to be more creative and work with the universities and colleges as well.
There aren't very many centres, I think, of this size that have both a university and a college with this amount of expertise in water, so we're very committed to working.
And we have quite a bit of private sector expertise in this area too. Some consulting firms and laboratories as well.
And I will cut it off there. Are there any final words from panelists?
Just this is a very optimistic group. I just remind you how important this example is, and this setting you have with universities and colleges, that we should be experts in this and show the world how to do it. Nobody else can afford to do it. If you can't do it in the Muskokas, or no one in the world can do it. So, you know, and it is a great opportunity for private enterprise and expertise that to transfer that knowledge globally, because this should be, you know, as I said in the first, Canada was famous for this, and we should get back on the security panel for water in the world. Let's not let ourselves get kicked off that panel as well.
Sure.
Yeah, I might just, as the non-scientist, I might just give a plug that we've got a wealth of expertise in this country that we should embrace and support, and help encourage our politicians to similarly embrace some of the good advice that's around. Nanos did a poll in 2009, and 90% of the people that they asked identified the most important government issue was to embrace overarching water policies that cross provincial and territorial borders. There's a lot of good science around that never gets down to the ground level, and I think that's it's up to all of us to expect that of our politicians. There's a provincial election coming up, by the way. So I'd like to encourage people to take a broad and long-term look on water in their own lives, but also to encourage our decision makers to do so. Thank you, and thanks for the opportunity. Thank you.
There's also a federal election.
Alleged.
Sometime. Yeah.
Yes, thank you for having the opportunity. I think it's just marvelous. It's a beginning. We as municipal councillors are trying very hard to educate ourselves by going to the forums that are available, to the opportunities that are out there, and I do think we need to get this. We need to decide what the real information is that we need to give to people so that they can turn things around, so they can change their lives, and we need to give it in simple, practical terms, and I think people are willing to do it, and they'll also get behind an institution like Trent. If we all want to lobby on these issues to upper levels of government, I think people are willing to do that as well, to advocate. So let's keep up the work then.
And Schindler Chair?
Well, I was just struck by what Terry was saying, because I think we should hold our politicians to what they're saying. And a couple days ago, I received a flyer in the mail from one of our local politicians saying that the government is protecting our precious fresh waters. And I can't read that and not first feel ill and then wonder how they can say that. If they are saying that, we should hold them to it. That's not true. And we should hold our politicians to truth, and particularly with our fresh water. And I'm not trying to make a political statement here. I didn't ask for the flyer to be sent to me. I'll end on that.
I'm going to pass this back to the old chair.
Well, we've had a wonderful debate. I'd like to thank Paul, our Schindler professor, for making the background, and our stakeholder panelists for really getting things going, and the audience. I just want to finish because I I won't have too many opportunities to talk to an audience like this. I just got back from Halifax. And in Halifax, I was at the right whale recovery program. Right whale is one of the most endangered species in Canada. There's 400 left. For the first while, we were exposed with pictures of right whales with ropes around them, around the flippers, the ropes cutting into them. 70% of all the animals have severe scars. What causes the scars? Rope pollution. Right? So we all like lobsters and we like fish, and these animals are being entangled in it. And so we spent some time listening to DFO telling us there's no money. $75,000 is all the Department of Fisheries and Oceans put into that species. So I think one of the themes was pessimism or optimism. After the first day or so, I was really cheesed off with the whole session. And everything turned around when an old Acadian lobster fisherman stood up and said, I want these animals to be here for my grandchildren. And he had changed his fishing practice such that he's reduced the rope in the water by 50%. He maintained his catch and, in fact, reduced some of his costs in terms of rope. So I think instead of blaming politicians all the time or expecting them to do things, we can all do things. And that guy showed us all a lesson, I think, and was going to do more for that damn right whale than the Department of Fisheries and Oceans. So I would challenge everyone to do their bit to make our water clean and make this planet better for our kids who come after us. So on that optimistic note, thank you.